All right, so I found out how to make myself stop sounding like a robot. So hopefully this video, the audio quality on this video is a little better than the last one. And if it's not, sorry. But this is video 2 of the Stoic series. In this video, we are going to continue to review Reaction Stoic. And now this is the very basics of Reaction Stoic. Please don't think that if you understand what we did yesterday and you're a master at it, that you understand stoichiometry completely, because in the next 2 videos I'll add another aspect to it, and then in the last 2 videos I'll add another aspect to it. So this is just kind of the foundation of it. So we're going to continue to talk about what we talked about yesterday with a couple more example problems. But before we do that, I would like you to pause the video and complete section D, which is the day 2 warm-up. It is 5 reactions that you have to predict the products of, and then balance, and then tell me the type of reaction for each. So please pause the video, complete those 5 problems, and then hit play when you are done. So these should be the answers that you got for warm-up number 2. The biggest thing for number 1, you should have found that there is no reaction because silver is not higher up on the activity series than hydrogen. Therefore, it will not replace hydrogen in this compound. So you should have gotten no reaction for that. And number 3, you need to make sure that you are putting either an S for any compound that is insoluble and an AQ for any compound that is soluble in your double replacement reactions, because that is the whole point of writing them out, is to see if the reaction is taking place and then to specify which compound is coming out of solution. Also, this +4 down here is not necessary. I just put it in so that you can be aware that in this case, the lead is a +4 charge, oxygen's a -2, so you would need 2 oxygens to balance out the +4 of the lead. But I probably wouldn't give you one of these on a test because I'm not that mean. So we are going to, in your packet, go to page 4. We are going over example problem number 3 and number 4 in this video. I'm hoping that at this point, as I go through the steps again, we can pause the video and try the entire problem on our own. And then when you hit play, I can show you what you should have gotten and you can check your work. If you seem to understand Reaction Stoic from yesterday's video, awesome. Why don't you try the example problems on your own first, and then just kind of click through the video to see if you're actually getting them correct. However, there are some points in this video I would like you to learn, so maybe listen through it and just deal with my voice talking at you for this video, just so that you get all of the details that you need to get. So the third example problem reads, if 20 grams of zinc reacts with hydrochloric acid, how many grams of zinc chloride are produced? So the first step again is to write out the chemical equation and balance it. So please pause the video here, write out the chemical equation and balance it, and then hit play when you are ready. So you should have gotten this equation with these coefficients. You just needed 2 in front of the HCl. If you did not get any of this, please take the time to pause the video and figure out what you did wrong, because again, if you don't set up the equation correctly or you don't balance it correctly, your entire Stoic problem is going to be incorrect. The next step is to go through the problem and to determine, there we go, what you are given and what you need to figure out. So please pause the video, try step number 2, and then hit play when you are ready. So you should have found in the problem that we are given 20 grams of zinc and that we want to find out how many grams of zinc chloride are produced. So I always write it out like this. You don't need to. If you just want to underline it in the problem, that's fine. But it's very important that you understand where point A and where point B are. Step 3 is to set up dimensional analysis and to put your given value in the upper left-hand box. Please make sure that you are remembering the label and the unit on every single number. So please pause the video, try step number 3, and then hit play when you are ready. So you should have put the 20 grams of zinc that we are starting with in the upper left-hand box. And again, notice on these very simple reaction stoichiometry problems, the number that you were starting with is always the only number given to you in the problem. Step 4 is to do a simple mole conversion and convert the mass that you started with into moles using the molar mass. So please pause the video, try this simple mole conversion, and then hit play when you are ready. So for zinc, you should have found, using the periodic table, that there are 65.4 grams in 1 mole of zinc. And since I have grams of zinc up, I need to put the grams of zinc diagonal, and you are always finding out how many grams are in 1 mole of it. Step 5 is then to use the balanced equation to determine the mole-to-mole ratio. And then we are going to use this ratio to convert from moles of what we started with into moles of what we are trying to get to. So please pause the video, try this, and then hit play when you're ready. So using this simple balanced equation, we see that for every 1 mole of zinc, we are going to produce 1 mole of zinc chloride. So because we have moles of just zinc up here, we need to do moles of just zinc diagonal. So we have the 1 mole of just zinc down so that these will cancel out. And for every 1 mole of zinc, you are going to make 1 mole of zinc chloride. So I'm going to put that up. We are now in moles of zinc chloride, so we are on our way to finding grams of zinc chloride. The next step is to do another simple mole conversion and convert the moles of zinc chloride into grams using the molar mass. So please pause the video here, try this out, and hit play when you are finished. You should have found, using some basic math in the periodic table, that 1 mole of zinc chloride is going to be equal to 136.4 grams. Please make sure that if the tenths place on any given mass is greater than 0.3 or less than 0.8, please keep it as a decimal, so please don't round this to 65. If it's 65.4, you need to put the 0.4 in because you rounding it down to 65 is going to be too much, and your answer is going to be a little too off to be marked correct. So you should have found 1 zinc at 65.4 plus 2 chlorine at 35.5 each should have gotten you around 136.4. And that is how many grams of zinc chloride are in 1 mole. And notice how we have 1 mole of zinc chloride up, we have to put the 1 mole of zinc chloride down, and then we put the grams on top. Step 7, we're almost there, is to make sure that all your units cancel out and that you are left with grams of what you asked for. This is an important step. It might seem like a trivial step, but it's very important because if you might have messed something up, usually the mole conversion or the mole-to-mole ratio messes people up, then you're going to get the wrong answer. So this is just kind of a safety check to make sure that you did it all correctly. A lot of people skip over this, and then when you skip over it, that's usually the time that we mess up. So please make sure you are doing step 7. So in this case, we have grams of zinc up and grams of zinc down. These are going to cancel out. Moles of zinc up, moles of zinc down. Those are going to cancel out. Moles of zinc chloride up, moles of zinc chloride down. Those are going to cancel out. So we are left with grams of zinc chloride, which is what we wanted. So we are good to go. Also notice how writing out the actual compound or element that we are working with each number and unit that we are putting in is very beneficial, because if we didn't put in zinc or zinc chloride on any of these labels, you could get extremely confused and then you could royally mess up one of these reaction stoic problems. So please make sure that you are putting number, unit, and label every single time. The last step then is to solve using your calculator. Make sure that you are bringing a calculator to class every single day for the rest of the semester. Again, you know my calculators kind of suck, so please make sure that you are bringing one or borrow one if you need to. So we're going to solve, pause the video, try solving it, and then hit play when you're ready. So you should have put in 20 grams times 1 times 1 times 136.4 divided by 65.4 divided by 1 divided by 1 to get an answer of 541.71 grams of zinc chloride. If you did not get this, please pause the video, plug it in again, see if you get the right answer. If you still don't get the right answer, please check with someone around you to see what you're doing wrong. All right, so I found out that I still sound like a robot, so we're going to try it again. And if I still sound like a robot, I'm so sorry. I am trying my hardest not to, but it is what it is. So we are going on to example problem number 4 in your packet, and that problem reads, how many grams of chlorine are added to react with sodium iodide if 10 grams of sodium chloride are produced? Now this problem is a little bit different because if you look at this, we are no longer starting with grams of a reactant. We're now starting with grams of a product and kind of working backwards. And this is very possible. You do it the same exact way, but it's just set up a little bit different. So don't get scared off. It's the same process. You're starting and ending with something different. So let's start with step 1. Please pause the video, write out the chemical equation and balance it, and then hit play when you're ready. So this is the equation that you should have written out. Chlorine is diatomic, so you should have put Cl2. It is reacting with sodium iodide. Sodium is a +1, iodine's a -1, so those are equal and opposite. They should cancel out to make NaI. I'm sorry the L's and the I's look the same, but you're just going to have to know that they're different. Those are going to produce iodine gas. So this is iodine's another diatomic, so you have to put the 2 by it. And then the sodium and the chlorine are going to be equal and opposite in charge as well to make NaCl. So this is a single replacement. It didn't say that iodine was being made, but you should know that chlorine, since it's above iodine in the activity series, was going to replace the iodine and thus giving you iodine by itself as a reactant. So just be careful when you're doing these. Sometimes not everything is given to you in the problem. The next step is going to be to determine from the problem what you are starting with and what you are asked to end with. So please pause the video, try this out, and then hit play when you're ready. So you should have found that you are starting with 10 grams of sodium chloride, and then you need to find how many grams of chlorine that you started with. So that is found here, 10 grams of sodium chloride, and we want to find how many grams of chlorine are reacting. The next step is to set up dimensional analysis and to put the value that we are given in the upper left-hand box. So please pause the video, make sure that you put a unit and a label on that number, and then hit play when you are finished. So you should have just put the 10 grams of NaCl in the upper left-hand box for this step. Pretty simple step. Step number 4 is to convert this mass into moles using a simple mole conversion. So we are going to find out how many grams are in 1 mole of NaCl, plug that into the dimensional analysis. So we're going to pause the video, do that, and then hit play when you're ready. So you should have found that there were 58.5 grams in 1 mole of NaCl. 1 sodium is 23, and 1 chlorine is 35.5. Add those together to get 58. And since we had grams of NaCl up, we had to do grams of NaCl down, and then we put the 1 mole on top. The next step is to use the balanced equation to determine the mole-to-mole ratio, and then we are going to use this as a conversion factor to go from NaCl to whatever we are trying to get to, which in this case would be the chlorine gas. Please pause the video, try this, and then hit play when you're ready. So we should have found from the balanced equation that for every 2 moles of sodium chloride, we are going to need 1 mole of chlorine gas as a reactant. So we are just going to plug this in the same way we have been. We have moles of sodium chloride up. We need to put moles of sodium chloride down. In this case, we have 2 from the balanced equation. And then we are going to put moles of chlorine gas up. And from the balanced equation, we know that we have 1. So again, this is a ratio. For every 2 moles of sodium chloride that are produced, you have 1 mole of chlorine gas going into the reaction. This is just backwards from the way that we were doing it. We were given a reactant, we were going to a product, but we can also go the other way. The next step is to then convert. Now we're in moles of chlorine gas. We need to convert that using a simple mole conversion into grams of chlorine gas. So please pause the video, do the simple mole conversion, and then hit play when you are ready. So since we have moles of chlorine gas up, we need to put moles of chlorine gas down. And when we are converting this into grams, we need to find out how many grams are in 1 mole. So we put the 1 mole diagonal, and we know that 1 chlorine is 35.5, but chlorine is diatomic, so we need to multiply that by 2 to get 71 grams of chlorine in 1 mole. The next step is to make sure that all your units cancel out and that you are left with grams of what you are asked to find. So please pause the video, make sure our units cancel out, and then hit play when you are ready. So you should have found that our units do in fact cancel out. We have grams of sodium chloride up and down, so those cancel out. We have moles of sodium chloride up and down, so those cancel out. We have moles of chlorine up and down, so those cancel out, and we are left with grams of chlorine, which is what we wanted to find. The last step then is to use our calculators and to solve. Make sure that you put a unit and a label on your answer. So please pause the video, try this calculation, and hit play when you are finished. When you plug this into your calculator, you should put 10 times 1 times 1 times 71 divided by 58.5 divided by 2 divided by 1 to get an answer of 6.07 grams of chlorine. If you did not get this answer, please take the time to try it again, and if you are still not getting the right answer, please check with those around you to make sure that you can figure out what you are doing wrong. Now that we have gone through the 2 example problems, you should be able to go on and complete section E, which is more stoichiometry practice problems like the ones we just did. There are answers on Google Classroom. Just please look for the section E answer key. If you are not getting the questions correct, please go back through the steps of the video and try and figure out where you are going wrong. And then when you finish section E, please go on and complete section F, which is extra practice problems. And there are answer keys for these also on Google Classroom. Just look for the section F answer key. And just so you know, there is the section F does go on to page 6. So there are 7 more questions on page 6 for section F.